All right, so the first thing we need to do is we got to get everything into grams because it's by mass. So we would take 100 milliliters of the ethanol and multiply by, for every 1 milliliter, you have 0.79 grams. Did you guys come up with 79 grams of ethanol? Okay, so then you would go ahead and take the 2.5 grams of sugar, and then you would divide by, what, 79 plus 2.5? So it would be 81.5 times 100. And that gets you your answer? Yep, 3%. It actually comes up to 3.1, but 3.1%. Good job if you did use the density. Okay, that's something we kind of worked on in the past. 3.1% sugar. Okay, pretty easy. Okay, well let's do the next one then, because we want to get through these, and you guys can work on these. So the next one's percent by volume. Same thing. Instead of grams, you're dealing with volume. So go ahead and plug your numbers in on that and see what you get. Percent ethanol that's in a water solution of ethanol. So go ahead and figure that one out. Again, we're always dividing by excuse me, the total. Okay, so this one would have been 40 milliliters of ethanol divided by, what, 290, right?
Oh,
And then that would give you your answer, right? And then so on this one, you'd have 13.8%. Okay. All right. Go ahead and turn it over. I'm going to let you guys do the next one really quick. So do that next one. I do not use percentages in chemistry. We do not use percentages in chemistry. We use anything that deals with moles and molarity. Biology people, they use this. They don't use anything with molarity. Okay? They're always based upon percent. Percent salt solution, percent this, percent that. They just deal in percentages. In chemistry, we deal with a more important concept we'll take a look at tomorrow called molarity. And it's not that difficult either. But it's dealing with moles, which is number of particles. This is dealing with mass. Okay, that's different. And so molarity is more important for us in chemistry because we always want to look at reactions and moles associated with reactions. Okay, so this would be what? 2 liters divided by what? 22?
yeah.
Okay, total volume. And so you get 9% or 9.1%. Propanol. Okay, really easy stuff. Now, what if a sample doesn't really make sense to use percentages? Because when we come up with the calculation, the percentages is so small that you're going to have to use zeros. Like 0.0005, something like that. It's like, oh, there's got to be a better way. There is a better way, and it's called parts per million. So parts per million has to do with a substance where it doesn't have a very good solubility and it doesn't dissolve real well. So we're going to have to use this thing called parts per million. Now, water, tap water, it can only, the tap water has regulations on it, how much parts per million you can have of different substances in it. If the city's putting out water that has above what they ask for it to be good for you to drink, okay, then they have to do something to clean it up. They got to do something to clean it up. We do not want lead in our water. We want 0 parts per million lead. If you got above 0 parts per million lead or any parts, that's not good. Because your body absorbs it and doesn't get rid of it. And then you can get really sick. Because it attacks the liver, it causes damage to the kidneys, those type of things. Because they're trying to get rid of it and they can't get rid of it. It's called a heavy metal. The heavy metals are lead, mercury, and silver. You don't want any of those in your body. Okay. So then when we do certain labs, we've got those milk jugs out, and we don't put anything down the sink because we put it in there. You guys remember we did that a little bit? Because if we put it down the sink and it's a lead compound, eventually it could get back into the supply of drinking water. If you do that over and over and over again. For example, I can't even, I can't order anything mercury. I used to have a lab I did mercury compounds. They won't let me order it anymore because the chance of getting in the water supply again is they don't want to risk that. Okay, so we have this thing called parts per million. It's just like percentages, because actually when you do percentages, that's parts per 100. So if we did this percentage here and we said, how else could we state that? That's 9.1 parts per 100. That's what it is. 9.1 parts per 100. So parts per million is, you do a real similar way. You can do it 2 ways. You can take the mass of the solute divided by the mass of the solution, times it by 1,000,000, or sometimes you're given milligrams per kilogram, or you can get milligrams per kilogram and it makes it easier. Because the difference between a milli and a killi is 1,000,000. So when you take a milligram divided by a kilogram, you get parts per million. So go ahead and do. Now, on these, you do not have to add in the 0.0075. And the reason why is because it doesn't really affect the parts per million. So on these, you don't have to divide by the total mass. Unless this is going to be a significant size. So go ahead and do those 2 and see what you get in parts per million. Parts per million. So, this water has to have less than 10 parts per million nitrate ions. Nitrate is an ion that gets in our water supply due to some different things like fertilizers, solid on the ground, it rains, gets in the sewer system, goes through the water treatment plant. Okay? Feedlots has all that manure, it rains, it drains down to the streams and rivers, can get into the drinking water. When they spray fertilizer, okay, those produce nitrates. And nitrates aren't good to have in your drinking water. So the first one, what's the answer? Parts per million. So you take, the first one you take 0.0075 grams of chlorines, and you divide by 50 times 1,000,000.
Oh, you have to do total on this?
You can if you want to, but it would be,
It's not going to make much of a difference.
it will not change your answer. Unless you take it out a long, long ways, and we're not taking it out that far. So that one would be 150 parts per million. Okay, 150 parts per million on that one. Okay, questions on that? Go ahead and do the next one if you did that one wrong or didn't kind of get it figured out. Go ahead and do the next one. So the next one, what's the parts per million?
66.
66. Thank you, .03033 divided by 50 times 100. And that's how much you'd have of lead ions. We don't want lead in any sort of situation because we can't get rid of it. Any questions on that? Last one, I want you to see if you can figure it out, and that'll be the last one we'll do, and then we're going to have you do guys some practice. Ainsley, are you working on the calculator on that, or?
Yeah, I think
Okay, so the last one. I see this a lot more, so that's why we introduced this. Because a lot of times you'll see, like, I had blood work done. And then you look at your blood work and you look at protein and different things in there, it'll say milligrams per liter. Or, yeah, per liter. And that's like per kilogram. That's what it is. And so they'll have those measurements on there when you take a look at it. So, on this one, we would take 35 milligrams, and then we would divide by a kilogram. Well, that's 800 grams of water, so how many kilograms would that be? .8, right? So, we would take,
What's a milligram again? Like,
what's that?
what's a milligram?
Milli's a thousandth of a gram.
1,000.
Yep. So what we can do is we can take the 35 milligrams, because we had that initial values, we can take milligrams over kilograms and get parts per million. So we got 35 milligrams, we can take it divided by 0.8 kilograms, and then that gives us our milligrams per kilogram or parts per million. So it'd be 44. Or you could have it as 44 milligrams per kilogram, and that's the same thing. Those are the same thing. All right, so what I'm going to have you do, and I'd like you to get this completed, except for number 9. I want you to do 1 through 8. Number 9, you'll keep for tomorrow. So do this for tomorrow. Try to get it all done. The 15 minutes is definitely enough time to get this done, because you're just repeating what we just did.
So you're like, I know the bathroom.
Wait, Garland, so do we do like a sandwich?
No. So, do 1, on this worksheet, do 1 through 8 for Friday. Okay? Hey,